All right, guys, welcome back to another episode of Within Tolerance, and we're joined with Justin, the Cogwheel on Instagram, and we're just gonna get right into it. So, Justin, tell us, how did you get into manufacturing? What age did you start learning about machining, maybe specifically, or maybe you got into this in a weird way? I know a lot of our previous guests have. So, just kind of take us through the motions from where you started to where you are now.
Okay, yeah. Thanks for having me on, guys. So my story, so my social media presence is, I just want to put this out there first, is mostly all hobby stuff. So the cogwheel, my handle, if you will, is sort of the hobby side of my life. Um, but I get the impression after listening to your show for a while too, you guys are kind of the same. Like manufacturing and machining is something that is not only a hobby, but also what I do. So the lines between your hobby and what you do for a living and all that stuff is all really messed up. Like I don't golf, I don't do sports, I don't do any of that stuff. So I have like hobby stuff, and then I have like the professional stuff, professional in quotation marks, and then everything else. So but it's always like all machining all the time. So if that makes sense. But I think there's lots of people in this industry that are like that.
Yeah, I definitely agree. I posted a quote the other day on my Instagram. It said, "Do what you love, and you'll work super hard all the time with no separation or any boundaries, and also take everything extremely personally."
I
And
Yes.
like
saw that.
everybody responded to it was like, "Yep, 100%."
Yep, yeah. No, I read that, and um I agree 100%. I think Dylan, you posted something else that I was like, yeah, you're right. I don't know if it was on the Discord server because I'm always there trying to stir up trash, it seems, but uh, I think it was something along the lines of like, if you really like running parts and making parts, you can take a job somewhere else, but you'll find yourself back running parts and making parts.
Oh yeah. Some guy was asking. He had gotten a chance to do a machine like fixing and maintenance apprenticeship instead of where he was currently. And he was, he's like, "Oh, I feel bad. I don't want to, forsake machining." And I was like, if it's in your blood, it's in your blood. Like, there's no ifs, ands, or buts.
Yeah, it will find you again for sure.
Yeah.
Um, but anyway, so how I got into manufacturing, the whole industry. So first and foremost, my dad's a mechanic and auto body repairman. So I grew up fixing cars, and being around cars a lot. I joke with a lot of my friends and family and acquaintances and stuff. I did a full apprenticeship on my first car. It was a '91 VW Jetta. Uh, it was a diesel, naturally aspirated diesel. It had
Oh.
52 horsepower. The only car in my life that I drove with your foot to the floor in every gear. Uh, but my dad's also actually a hobby pilot. He got his pilot's license when I was quite young, actually. So I ended up spending a bunch of time around airplanes as well, at the local airport when I was a teenager. My dad also built a couple airplanes in his basement. He was one of those guys. And but it's super interesting when you're that age to be exposed to sort of aircraft and cars and all that stuff. So I had this very mechanical upbringing. Uh, and then, of course, your dad being a mechanic, when you're fixing things, he's always complaining about how the designer screwed up in this way or how they should have done it better this way. And so, yeah, I was really, really mechanical when I was younger. I also, like your previous guest that you had on, Jeff, I come from a rural area, so I attended a rural high school. And a lot of rural high schools even here in Canada had excellent shop classes. So I took a lot of shop classes when I was in high school. I started taking manufacturing in grade 10. So that was the first time that I actually started machining. And the shop teacher that I had was fantastic. He was basically straight out of industry, and he was a tool and die guy. And he pushed us really hard, even in grade 10. Like we were turning diameters to within a thou for our exams and tests, which looking back on it, it's pretty crazy. But I was really appreciative of him pushing us so hard. And those skills that I learned in high school shop class have come with me to this day. And part of me is really sad because if I don't know what schooling's like in your areas, But again, I have 3 kids. I know you guys don't have kids yet, but high schools have really gotten away from shop class, and that sort of scares me a lot, especially when I think about my kids as they grow up and determining what they want to do. But I guess we can talk about that later.
Yeah, no, I definitely echo that sentiment. The high school I went to considered it a college prep campus in quotations. So the nearest I had to take theater productions to handle any kind of power tools or anything like that. Like that was the only thing on campus that involved building anything.
Right. And I think we're doing our children a disservice by not exposing them to working with your hands. It's maybe a bit early already for me, although with the Home Shop Machinist podcast, if anybody listens, is just a giant show with tangents everywhere. I already feel like I'm going off on a tangent now, but one of my favorite books is Shop Class's Soulcraft. And I don't know if you guys have ever had a chance to read it. I know, Peyton, you're too busy to read books, but if it's a fantastic book that I tell every child, or not child, they're not child anymore, but teenagers who ask me, because I run into a lot of kids, they say, well, I'm not sure what I want to do. And I actually recommend this book, and I have a copy that I loan out for them to read, but it's a fantastic read. And essentially the essence of the book is this guy who completed his doctorate in philosophy was working at a job he hated, and then he started a motorcycle repair business that he loved. And he talked about, working with your hands in this book a lot, how it's not only good for the mind, but it's also good for the soul. And he had a lot more purpose in his life when he was working with his hands. So excellent read. If you have anybody who wonders what they should be doing, definitely pick up that book. But anyway, so that was sort of high school. That's where I got exposed to manufacturing. And then I went to college, and I made my mind up about 2 things regarding post-secondary school. One was I had to be able to live at home. I am half Dutch, so I'm extremely cheap. And so I wanted to minimize the amount of debt that I would incur going to post-secondary school. And living at home was an easy way to cut down on expenses. And I realized even then I had to do something mechanical. So I enrolled in a local community college in mechanical engineering technology, which I think we can talk about what is a technologist, because I don't think it's really popular in the States, and it depends on what area you're in. But so that's the program I enrolled in. And looking back, I was thankful that I did. I was hesitant at the time about it because I'm like, well, should I be going to university doing mechanical engineering, like a full blown mechanical engineering degree, or do I want a program that is a little more hands-on? This program was very much hands-on from a design standpoint, and there was about 25 students in our class, which was really small, but turned out to be really good. And I also was extremely blessed to have 2 teachers in that class that were fantastic. And I listened to the show from Tom that when you guys had Tom Lipton on, and I really love that show. And one of the things in the show that stuck with me the most, out of all the things Tom said, because Tom's just is a legend, really. And but the thing that stuck out to me the most, and it's something that I realize how much wisdom there was when he said it, is if you can find an old guy and develop a relationship with him, basically corner him and talk to him as much as you can. And
Isn't that the truth, though?
Yeah.
It's just, fantastic advice. And I had teachers in this program who were they were getting close to retirement, but they weren't faculty fossils, if you will. They were still very passionate about teaching. The one guy was hilarious. He had his cell phone I'm not that old. The teacher actually had a cell phone, and he had a belt, and he tied his cell phone, like he tied a shoelace around his cell phone, because if he dropped it, he could easily like retrieve it. He didn't have to bend over.
Oh my god.
But this was the same guy that was showing us how to set up all these equations in Excel. He loved Excel, so he had all these like sine and cosine equations in Excel, and he was he's this guy 75 years old teaching kids who were like, at the time we were like 19 or 20 years old, on how to use Excel, which was crazy. But um, anyway, so that particular teacher was extremely gifted, and I don't know how he ended up in this college, but he actually worked on the Avro Vulcan, which was a 1950s British jet bomber. And I remember him telling us his first job out of school was to design a machine that shot flies at the leading edge of this airplane. So he had to
What?
design this little pneumatic device that shot frozen flies so they would stick to the leading edge, because they were in the wind tunnel and they wanted to see exactly how bug buildup would affect the airfoil of this
Oh my
airplane.
god.
Bug buildup.
Yep.
Yeah.
And but
Wow.
this guy wrote all his own textbooks. He was fantastic. And the other teacher I had who influenced me greatly, and we'll talk about it a little more, but he was a mathematician and statistician, and he worked on North Sea oil drilling rigs, and he specialized in reliability. And so those two guys taught me basically everything from a college standpoint. And uh, looking back, I'm amazed at how much they influenced me and my thinking. So I graduated from college. I did a bunch of work in forestry equipment design. And then that was a co-op job. There was a co-op program, so that also helped pay some bills. That was a really good idea. Anybody looking to going to school, definitely consider co-op or work placements. I know in certain areas of the United States, there's a heavy influence of internships. Um, Now, some of those are paid and some of them aren't. I don't really like the idea of not getting paid for working, especially when you're in college. But hey, that's just my opinion.
Yeah, I
Uh,
think a lot of them are going to that too, because why pay for labor when you can get it for free?
Yeah,
Um,
and it's sort of this idea of competing. I always think as an employer, you want to sort of develop a long term relationship with some of these people, and I think paying is a really good way to develop a relationship with very bright people. But hey, that's just my opinion. Um,
yeah. Well, I mean, I feel like it's a sign of our culture too. We've got, if you have a photographer friend or something, people are always like, "Oh, why don't you come do my photography for free or for the exposure?" And it's like the same kind of, reasoning that they use for unpaid internships.
yeah, it is kind of crazy, but anyway, so after school, so this is sort of a roundabout way to answering your question, but looking back on how I got really into manufacturing is sort of the point of this story. So I ended up working at a small company who they designed and manufactured small hydraulic valves for various mobile equipment industries. So it was construction, forestry, all that stuff. And at the time, they were a very small company. They outsourced all of their production, like everything, and they just did assembly. And the majority of that production at the time, so this would have been, I don't know, 15 years ago or so now, maybe not that long ago. I was right out of college, was all being done mostly on screw machines. So I don't know if you guys are familiar with screw machines. Uh,
Yeah,
the
actually, my first machine shop job was working with them.
Okay.
Yeah, interesting memories.
What were they? I'm just curious. This is a tangent again, but Brown and Sharps, or were they
Yep, all
Davenports? Or
Brown and Sharps.
okay, yeah. So they had the majority of their product, and screw machines are fascinating pieces of mechanical design. If you want to go down a rabbit hole of sort of manufacturing history, I think there's definitely a book devoted to screw machines, uh, because like I believe the Davenport, which is probably the most ubiquitous screw machine aside from the Brown and Sharp, but the Davenport was a 5 spindle screw machine. I think it was. I think the first model came out somewhere in 1912.
Wow.
Um, and we're talking about a machine that is 5 spindle, fully automated, and is extremely quick. Um, Parts that would normally take, if you put them on a Swiss machine, at least this has been my experience, it may take a minute on like a Citizen or something like that. If you could get it to run on a Davenport, you could have a cycle time of around 13 seconds.
Wow.
Um, So that definitely is crazy. Now there's all kinds of reliability issues with running screw machines, process reliability issues specifically. So that's why I think they've sort of faded off into the sunset. That, and it's difficult to find good screw machine operators. But um, anyway, so the shop that I worked at, they were outsourcing all of this stuff to screw machine shops, and in order to get good pricing, they'd buy like large quantities of product, like sometimes years worth. And as a design person, it's extremely frustrating because you're like going to design something and they're like, and it's a small business. So it's like, well, I want to cut in this design change. And the owner of the company's like, okay, like when? And I'm like, well, can we do it as soon as possible? Well, that means scrapping all the inventory. We're not going to do that.
Ugh.
And it's just like, well, so how am I supposed to exactly do my job? We're trying to make your product better. And I sound more frustrated than I am, but it was very frustrating actually. And we talked about it, and essentially we came to the conclusion there was no quick way to prototype. We had these huge piles of inventory that sometimes you'd have to wait 2 years to burn through. And I said, like, something's got to change. So they had a few good years. They had a really good product. It's they're still in business today. It's a fantastic product, but somehow I convinced them to buy a CNC lathe and bar feeder. And it wasn't just any machine. This wasn't a used machine. It was a brand new multi-axis Swiss type machine. The reason that this is a little shocking is because I had no CNC experience.
And the journey begins.
Yeah.
So this machine, the machine's still in production today, but it's like a Swiss machine, but it doesn't have a guide bushing, so it's it's like a Swiss machine in chucker mode, they call it. So the Z-axis moves, Z-axis, and there was a gang tooling and live tooling on the main spindle, and then there was a sub spindle with another 3 axes, so you could do full overlap work. So they bought this lathe, they put in this bar feeder, and that was me being thrown into what I call manufacturing.
Jeez.
Yeah, I could
Quite
run
the
a manual.
introduction.
Yeah. And looking back, when you get older, like when you're like your age, Payton, it's like, yeah, I can do this, right? And now that I'm a little older, I'm like, I don't know if I'd do that again. But all jokes aside, but thinking about it, like I had no experience with modern manufacturing processes. Like I ran a mill in high school and a lathe. We had some shop classes in college, so we turn this diameter, do this, blah blah blah. But like I didn't even know what the naming convention was for a carbide insert, or what coatings did, or what's a solid carbide coolant through grill.
Oh, jeez.
And I didn't know what G code was. They didn't taught us that in school, like, because I was in mechanical design, so we focused on mechanical design, not manufacturing. And I had no process engineering experience. So just because you get the thing set up, how do you make sure that the next 1,000 parts that you're going to run are going to be in tolerance and acceptable for assembly to put together? So I guess the long and the short of it was I learned a lot in 2 months.
Oh. What machine was it? Just because I'm curious.
Okay, so yeah, it was a Miano. So now anybody who
Thought it
follows
must
me on
be.
Discord knows why I'm this big Miano fanboy. It was a Miano, a BX26S is the model of it, and it was I could talk about CNC machines all day, but it was a bit of an oddball. This was before 2008, so before the Great Recession, and Miano was a company that was building lathes and mills, and I think they built a bunch of other stuff, but really good Japanese machine tool company. But essentially, they were bankrupt, and 2008 came along, and that basically pulled the plug on them. But this machine was before that bankruptcy, so this was Miano's answer to compete with the Swiss market. in the way Miano did their things. So this was a citizen competitor, if you will. Post 2008, because like most things in Japan, I don't know if you guys follow Japanese machine tools, or sort of the weird way the Japanese government works, is that basically the government moved in and said, this industry or this company is too important to allow to just go bankrupt. We're going to facilitate some sort of takeover. And that's where the Citizen Miano merger came out of.
Oh, wow. That's really interesting.
Yeah,
Yeah,
I knew
so
System Bottom, but I didn't realize that it was kind of a government deal.
the government was heavily involved, and because of that merger, Citizen had their full line of Swiss machines. They wanted it was a good fit with Miano because Miano was all fixed headstock stuff, and it was larger diameter mostly. But Miano did have some smaller machines. Citizen just came and said, "Sorry, that stuff's all gone. We're not making it anymore. You can buy a Citizen if you want small bar stuff. If you want big stuff, you can buy a Miano." Makes a lot of sense. The problem is that when you've got an oddball machine, um, all of a sudden it becomes difficult because the company actually did want to buy another one of these machines um, to increase production, and then the easiest way is just to buy exactly the same machine, and you can't get it anymore.
Oh.
But so that led to them buying their other machines, the turret machines that they have. They're all Mianos as well. But uh, anyway, so yeah, that was the machine um, that I started on, which is kind of crazy.
Yeah,
Anyway,
seriously. Like, talk about, going right into the deep end of it.
yeah, it was, and it it was challenging, and yet I think in some ways it was a good thing. I know I dealt with a lot of local tooling suppliers, and they actually came by and said, in some ways you didn't have a lot of history that like maybe people who've been in industry longer had to fight, uh, which is probably a good thing. I guess you can try anything, but you still have to still learn a lot of the principles that would have been a lot easier if I had some more experience. But anyway, it all turned out really well, actually. And that's sort of when I was really bitten by the manufacturing bug. It was a lot of work and it was really challenging, but I loved it, and it was worth all the extra hours that I spent doing. You guys know the feeling, like programming till 12 in the morning, reading stuff. It's just nonstop. And uh, around this time, crazily enough, I convinced my wife that I needed a manual machine shop in my garage for some reason as well. So I dragged home a lathe and a mill, and um, and initially, actually, it went into my basement, and my wife was actually 3 months pregnant with my with my son, our first child, and she was helping me carry a lathe down the
Oh
stairs.
my god.
Oh.
And I'm like, we got halfway down, and I'm like, I don't know if you should probably be lifting this. And she says, well, I think I'll be okay. And afterwards, looking back, it was kind of silly, but it all worked out fine. My son doesn't have any, he was born fine. She never had any issues, but I'm like, I don't know if that was a good idea or not, but
Live and learn.
yeah. So anyway, yeah, that's how I knew, I love my wife. I wouldn't trade her for anything. If you have a woman who will help you carry a machine tool into your basement, yeah, that's
Especially while pregnant.
yeah, while pregnant. Yeah.
Oh.
So I dragged this thing in the basement, and I did that because I was like, I love this machining stuff, and I do this CNC stuff at work all the time, but I just want to make parts in my basement too. And that's when I really sort of got into the manual machining thing. That's when, sometime around there, a couple years, we started the Home Shop Machinist podcast. I subscribed to the Home Shop Machinist magazine. And even though I work every day with fancy equipment and do sort of all sorts of like process engineering type stuff, I really love the hobby side as well too. And then shortly after that, I picked up the strange hobby of filming stuff and posting it on YouTube and being shocked that people actually like watching it. So that's sort of how I got in the home shop side. And then at the company I was working with, where I put in the CNC lathe and bar feeder, they put in more turning centers. We also started up a prototype area for really small volume stuff and for stuff that was relatively simple. And for that, we put in actually a couple Tormach machines. And what else? And then the rest of my work there was mostly regarding reliability and testing work. So I'm very interested in reliability because of the teacher that I had. So I did a lot of work in that. But I guess that leads me to sort of the next thing, which I'm sort of rambling here, but we live in a credential society, unfortunately, for better or worse. And I guess that's a good thing and a bad thing at the same time. A lot of schools don't do a very good job teaching people, and there's stories all over online. You can talk to a relative who went to this program. The teachers were horrible, uh, whatever. They didn't learn what they needed, and they ended up with a bunch of debt at the end of the road. But unfortunately, on the other side of the coin, there's lots of people who lie on their resumes as well. So, post-secondary education is one of those things where I think you just need to be careful and you need to pick your program wisely. Like I have the most respect for all these for self-made people, people who learn what they do and why and do a really good job at it. I think that from a career standpoint, if your intention is to run your own business, I think that works out fine. But if down the road you want to do something else, like maybe you want to teach or maybe you want to change what you're doing, it's really hard for you just to say, "Well, I've done all this stuff. Uh, sort of, can you give me a job?" Do you know what I'm saying?
Yeah, definitely. Everybody looks for, oh, did you get your bachelor's? Did you get, this, that? Definitely.
Yeah. So, um, I have the most respect for small business people, and I think that what they do is fantastic. And I think for me though, I was like, I've done some of this work in manufacturing, and I didn't have a bachelor's degree, and I was like, well, maybe I should go back to school. So I enrolled in a program at a university that was not super close. It was still driving distance. So I did the night school um, engineering thing for 4 years. Um, so I was working full time and I was going to school. That in
And had a
itself
kid.
was challenging. Uh,
Yeah, I bet.
um, but in the end, looking back, I think I can't remember how long I've had the degree now for, maybe 5 years. It was worth it. It was a program that wasn't a classical engineering program. My bachelor's degree is in technology again. It's in manufacturing engineering technology. We can talk about sort of a technologist a little later, but uh, the program that I ended up enrolling in, the head of the program was one of these guys. He was a guy from Singapore, and he was one of them rare people that you run into who is not only extremely book smart, but has street smarts as well. It's one of the few people that I know that have published. He's has at least 15 papers that he's published. Obviously he's got his PhD, but he can walk up to a Finot controller and start programming it. And I haven't met too many people like that in my life. And he was the guy who basically was running this program and was putting together a team. So when I started, the program was very small, and then it's been growing. And I took classes in control theory, vibration, mechanical design, and a lot of process engineering stuff. And that really opened my eyes to the benefits of learning from really good people. I think the internet is a very good source of information, but if you can find somebody that's willing to teach you, whether it's through a formal institution or not, you really need to hold on to those people. And that goes back to what Tom said. Like, if you can find not just even an old person, but any person and corner them and get them to help you and get information from them in a way that sort of benefits you both, always do that. Uh, So in that program specifically, there were, like I said, numerous classes, and then there was the quality assurance class, and I thought it was going to be another one of those, like let's learn control charts. Have you ever plotted something on a control chart before? And and if you're in quality or you know control charts, you know exactly what I'm talking about, because we've all sat through those. I don't want to call them useless, but um, I don't know. I don't know. Can you help me out here, Dylan? What would you call this?
Monotonous,
Yeah,
repetitive.
yeah, like no, I'm sorry. Control charts and lean aren't going to solve all my problems. Because for some reason somebody in management said, "Hey, we're going to do lean and we're going to try it for 6 weeks and see how it works out." Like,
Right. Yeah,
um,
exactly. Well,
like
and they all like everybody has their own twist on control processes, and so they come up with a new buzzword and then try to feed you the exact same information for the 30th time.
yes, yes. So I'm just like, you guys have had Jay Pearson on. I love Jay. What he's doing is phenomenal. He's also, I think he should be the proper poster boy for lean, and I mean that with the utmost respect. And I think he's embraced that, and I think that's fantastic for industry, because the only way lean works is the way Jay is doing it, and it's from the top down, and it's like a fully devoted, 100% committed approach.
Very true.
If you
Oh yeah.
do it that way, you're going to make piles of money. If you don't do it that way, all you're going to end up with is a bunch of frustrated employees, or you'll frustrate yourself. Like if you're working by yourself, it just won't work. Like, but anyway, so I was sitting in this quality assurance. I remember sitting there in the first night that I was there, and I'm like I really don't want to be here. I've taken this stuff before in college. And the professor walked in, and she was a fully fledged process engineer, and boy did she wake us all up. Boy did she wake us all up really, really quick. um, she had this personal mission to make manufacturing better, and basically all forced us to do essentially a master's course in quality assurance. She was this she knew like Edwards Deming directly. Like, she took classes from him when he was still in the United States.
Jeez.
And she worked in, primarily it was silicone work, like for electronics, but she also did manufacturing work. So there, where they took Six Sigma extremely serious. And she introduced us to something that I actually never heard of up until this time, is design of experiments. Now, I don't know, have you guys ever heard of design of experiments before?
Only when talking to you.
Yeah.
I know I messaged Dylan, and I'm sure you sent it over to Payton. So she introduced us to this idea of using something called design of experiments to solve your problems. And it's something I never heard of before, and I can't believe why, because once she started teaching it to us, I was like, light bulbs started going off in my head. Um, and I part of the course was to use a design of experiment. You actually had to do a design of experiment as part of your coursework, and you prepare this is the thing about academia that sort of drives me bonkers, and drive anybody who's in small business bonkers. You need the 40-page report that goes along with it, and that takes you, I don't know how many nights of work to hand in. So there's a lot of stuff you're doing there just to get your mark. But the actual design of experiments, I actually did at the place that I was working at one of the CNC, like it was on a Miano BNA machine with a turret. And I remember I was pulling my hair out with this job, because it was one of them classic cases where, so I'll set up what we were trying to do. So there's 150 thou, like decimal 150, blind hole at the bottom of a 2-inch bore. Not 2-inch bore, like not 2-inch diameter. It was 2 inches in depth. So basically, we're trying to bore a 150 diameter hole 2 inches deep, and we had to hold it to within a thou, like a thousandth of an inch. And not just for one part, but they make 10,000s of these parts every so, like they use thousands of these things every day type thing. Maybe not every day, but the thousands of parts of this every week. They were making hundreds of thousands of these things on one machine a year. And every so often, there would be a part that comes out oversized. And it was random. And it didn't matter which machine this was on. So this wasn't machine dependent. It was coming out every 50th part was oversized. All the parts before measured fine, and they were gauging them with an air gauge. And all the parts afterwards were fine. But that 50th part or that 49th part or that 55th part would be bad. And right there, when I encountered this problem the first time, I'm like, okay, so anytime you inspect something where you say all the 50 parts before this are fine if I measure this one part off the machine, that's not necessarily true. Just because you walk up to a bucket full of parts that you think are good because you measured the last part off the machine, I wouldn't bet the bank on that. So that's something that I learned really, really quick with this problem. But the other problem, because of that, was essentially we were 100% checking this dimension. So every bore had to go through an air gauge. So the operator would clean the parts, put them through the air gauge, and inspect them. Well, on a part that were like, these were parts that were previously run on a screw machine, like we needed to be cost competitive. That's a really hard pill for people to swallow. So I said, you know what, let's take what I'm learning in this class and let's apply this design of experiments to it. And what design of experiments basically is it says my process is essentially a black box. I don't know exactly what goes on in this process. It isn't one of these things where we try to solve all these physics equations to determine exactly how this process works. No, it says I have no idea what goes on in this process, but I know all the inputs to the process. And for most DOEs, it's easiest if you have one output. So in this case, we were measuring a dimension with an air gauge. And it says, let's vary the inputs in a organized fashion and set up an experiment. So in this case, I decided that let's take, we're going to do the classic ones, the speed, the feed. They had high pressure coolant on the turret. So we did high pressure coolant. And all those things were either high or low. So you take a stab at it. You say, well, this is the lowest feed rate I think I can run it at. This is the highest feed rate I think I can run it at. You do the same thing with the speed without having the tool explode or something like that, within reason. So you do have to educate your guests where your starting points are. And then like I said, we did the same thing with coolant pressure. We did the same thing with tool, actually. So we had tools that came from our supplier. We had one that ran X number of parts, and then we had a brand new tool. And there was a few other things that we did. But essentially, you set up this experiment and you use a piece of software, or a piece of software makes it easier. We used Minitab. I don't know if you guys are familiar with Minitab.
I've never heard of it.
No, so Minitab, there's other companies that make statistic software. Minitab is by far one of the more popular ones. So essentially, it's like you can do all of this stuff in Excel, but Minitab is set up in a way that is much easier and quicker for you to do this type of work. You set up your DOE within Minitab. You run your experiment. So you'll set up a plan. It'll tell you, okay, so for this particular part, we're going to run the feed at high. We're going to run the speed as low as we think we can get away with. This is what the coolant pressure should be. They had 1,000 PSI on the turret, so it should be 1,000 PSI. And then the next run, we're going to put it down at 50. We ran the experiment, and to my amazement, we actually identified what was going on. Oh, one of the other things that we varied was the pre-drill size. So before we go in and bore this particular diameter, I played with how much material is still in the hole. And I guess I should say that we went through all kinds of the traditional machinist reactions to stuff like this by varying this stuff all out of our head, working with a tooling supplier, getting different number of flutes, getting different geometry, going with like a single flute tool, all this stuff. So basically what I was saying is that we were at our wits' end. We ran this DOE, and what we discovered was that there was essentially an interaction going on with the high pressure coolant and the pre-drill size. So I always thought, well, hey, let's run the high pressure coolant at 750 psi. Like, we're going to get those chips out of there, and the finish was really good, but we got to get those chips out of there, and that'll give us the longest tool life. What turned out being was that if we ran the coolant pressure at around 400 psi, the 50th, the part that showed up every time, like at 50 or so parts, went away.
Really?
Yeah. And it's one of those things where you would never have, like, I never would have intuitively said, let's turn this coolant pressure down to 400 psi. And so the one nice thing about Minitab is it gives you, after you run this experiment, and I'd love to do a master's class on DOEs, so I can't do the sort of the process you go through justice in the time we have here, but they give you all these charts where you can see if you want your diameter to be this, you need to set all your process parameters at this. And it was I did the actual experiment in one evening. It wasn't a school night. I went there, I set the machine up, and I actually did the whole experiment in one evening. I spent another couple evenings interpreting the data, and then I spent the rest of whatever typing up a report, but that doesn't matter. But essentially, I came out of this with a recipe to get rid of this problem, and I was shocked. And then that's when I was reminded on sort of the importance of learning from people who are smarter than you. And I'm like, yeah, Lynn is her name. She really knows what she's talking about. She's done this before, and she kept telling us, you can save yourself a pile of money if you learn how to do this. And I experienced that firsthand. And it's one of those things where I think as machinists, like, we're all process engineers. Like, I put engineers in quotation marks because depending on where you live, you can or you may not be able to call yourself an engineer. Where I live, I can't call myself an engineer because that is protected under legislation. Australia is the same way. I think depending on which state you're in, you can call yourself an engineer or you may not be able to. But as machinists, whether you're a guy running in your own shop, or you maybe not a home shop machinist, they don't really care, or maybe you truly only do one-off works. That's where it's a little bit more difficult. But we're all process engineers, so when you have a tool break, like, what do we all do, right? Change the speed, maybe call somebody and ask, hey, can I get some operating parameters? But what design of experiments taught me was that there is actually a methodical way that you can get the information you need to make your process better without just grasping at straws all the time. Because I don't know how many times, I'm sure you guys can relate, how many times you're standing at 1 a.m. and you're like, I just need to get this job to run, right?
Yeah.
Yeah.
That's our next
100%.
t-shirt.
Yeah. Oh my goodness.
And I thought, like, with you, Payton, because you do injection molding, so if you're doing a large run of stuff, so I realized that some of this stuff, like, you're sitting there at 1 a.m. and you just want to get the job finished because you got to get that job out to pay the bills. But if you're running a job that comes up again and again, and you're like, I've been having a problem with this, and I don't want to do 100% inspection, or I want to make sure that it releases from the mold every time it should, maybe it's worth the time to do some process engineering to get that process stable so that you know exactly what you're going to get into, when you set that job up the next time. And
yeah, I mean, totally makes sense. Same with just machining parts in general, I feel like, right? I think that's what I enjoy so much. You get a file and you look at this and you're like, okay, there's no guidelines, but what's the best way to do this? You're thinking not just op 1, but you're thinking op 5. How do I hold this thing and nail that, plus or minus 2 hole tolerance or whatever?
Absolutely. So the other thing that went off in my head when I learned this DOEs is because, you hear everybody talking about artificial intelligence.
Mm-hmm.
especially with like industry. What are we at? Industry 10.0? No, I don't know. Seriously, is it 5.0?
Something like that. Yeah.
Something, yeah.
And they say, well, we have all this data and we're going to try to optimize the process for you. All of that's based on essentially design of experiments.
Yeah,
They're
that makes
just
sense.
they're automating the process. So yeah, if you do one, you still have to sift through the data yourself to say, hey, this looks like it could be really important. This graph, the way it's shooting stuff out at me, I understand. Maybe the feed needs to be dropped down or whatever. But that's what everybody's promising. But my point is like, just put the artificial intelligence aside for a moment, and why don't, if you're working in process engineering, if you're running parts on your own machine, maybe take a step back and say, hey, there are tools out there already to help you do your job. And if you actually talk to people who are um, the teacher of this course, she was a lean black belt person as well. A lot of the really good black belt people, not just the people who put black belt on LinkedIn, but the people who actually solve problems for people, they know about these things. And a lot of people in engineering do know about design of experiments. But I am amazed at the number of people who I encounter, because I go on like manufacturing tours in my area too. And I always ask people, hey, do you guys got people here doing DOEs? And these are fairly big companies. And I sort of get blank stares. And I'm like, well, no, like it's a process that you can use to make more money and keep your business, in the black, and to provide good jobs for the people that are in your community. So, of course, then they're like, "Oh, what's this?" So you start talking about that, and then you go down the rabbit hole, if you will. But um, yeah, there are lots of tools out there to help us all in process engineering, because ultimately that's what we're all doing as machinists. And I'm not talking about the guy who just loads parts in and pushes the button. That's not. I think we call those people button pushers, right? But um, but the people who like are doing the programming, who are setting up, who are dealing with this stuff on a day-to-day basis, like maybe once in a while, let's like use the data to work for us. So I guess I
Yeah.
could maybe put my soapbox away. I feel like I've been preaching, but
No, I think it's a great point. And like, I'm looking at a flow chart of design of experiments right now, and it's really just using the scientific method in manufacturing. I mean, it's no different than any science experiment. It seems like you define your problems, you determine your objectives, you conduct tests, analyze the data. Like it's all right there. It's just using it in manufacturing. I think it's pretty novel, at least for coming from a machinist perspective.
yeah, absolutely. And DOEs are extremely popular, I think, in the automotive industry, because they may release a design where there's maybe hundreds of things that they need to test, and they will to save you from testing all the combinations like individually. DOEs allow you to layer up that stuff. So I don't know if I did a good enough job explaining that earlier, but when I did the DOE on this particular part or project I was talking about with the small bore in a blind hole, I didn't have to run all of the experiment changing one variable at a time. You can change multiple variables each time. So you can get the experiment done quite quickly, as opposed to testing each one individually. Does that make sense?
Yeah, yeah, totally.
So you could
And
change like feed rates or your coolant pressure and it would know.
Precisely. Yeah. So the one job may have the coolant pressure high and the feed rate high. The next time you run, and your pre-drill size may be a certain size. So I think I had 4 or 5 factors in the first time I did a DOE. You can add numerous other factors. For you to be most successful, the best way is to have a measurable output that you can gauge properly. Binary outputs are possible, but it makes the data a lot more fuzzy. But if you have a dimension you want to control, or something like that, that makes it really good. So other people in my class did a lot of stuff with. I had access to a full machine shop, so that's what I did. Other classmates that I had, and we were all working, but they couldn't get in or whatever. They did a lot of 3D printing stuff, or so they would vary the speed, or maybe they would vary the diameter of the PLA or something like that, and got more stable processes through that, or maybe they used that to calibrate their printer somehow. So that's what they did. But since then, I've used this numerous times to solve really difficult problems. Would I use it to solve something that you could fix simply? Of course not. That's really silly. But if you've got something that you really can't solve, and you're like, how am I gonna fix this, or how am I gonna make this better? It's a fantastic tool, and it keeps you from stabbing in the dark and changing stuff and never really knowing why what you did worked or didn't work.
Yeah, that's awesome. And I really do. I mean, putting AI aside or whatever, but that is like exactly what machine learning is all about, is identifying patterns in a data set. So like I totally see that as the next step for this kind of thing.
Mm-hmm.
So that would be really cool.
So that the manufacturing class was really influential to me to this day. Since then, basically, since I completed school, I basically now I do consulting work. I really don't like being called a consultant, but unfortunately, it's one of those terms everybody understands. Uh, but I do process design work now. I do a lot of programming for companies on difficult programs. I am a lathe guy, so forgive me, guys. I know you guys
Yeah.
are.
Get out of here.
Oh boy.
I use finger cam for 80% of the work that I do. I know that's like that's almost heresy in the mill world, and I get it. I totally get it. But
That's not fusion. What is that?
what, finger cam? It's fantastic. The subscription fees are very low.
I bet.
So I'm a lathe guy. I still do mostly lathe stuff. I don't do, other than my home shop. We can talk about that maybe later, but I have a mill in my shop now, but I don't know. I just find, maybe I'm going to get into a cam rant now, but I just find, I don't know, posts for multi-axis lathes and going through that whole process to get a good post that works with all your configurations of tools in the turret and everything else is just really frustrating. I don't know. So that's why I ended up basically, I use Fusion and Esprit for generating complex code that I basically cut and paste into a program. But I use templates. So I have like safe tool change templates and all that stuff, and I cut and paste stuff in. People are probably cringing, but
If it works, it works.
I don't think I'm the only lathe guy that does stuff like that. For a mill, if you've got like a 3-axis mill, I fully understand that you need a good process or a good post processor and a good workflow. Every time you hit post, you should be able to run it on the machine. And I get that. That totally makes sense. For lathe stuff, I don't know.
Well, and like good lathe, multi-axis lathe posts are, you either have to have them super dialed or you have to pay a lot of money to have them super dialed. So I don't begrudge you for hacking together some stuff.
Yeah, well, and the thing that I found with, I kind of went down this with the first machine that we did. They were interested in getting cam, and they went with Esprit, and that was fine. But because it was an oddball machine, and lathes often are a lot more oddball than mills are. Like mills are usually pretty straightforward. A mill's a mill's a mill. Like a 5-axis even is a 5-axis for the most part. Like I know there are exceptions, but lathes seem to be like, some people put the turret on the bottom, some people put the turret on top.
Things get weird quick.
Yeah, and then with this Miano machine, it was a real oddball. So the whole experience of going back and having them edit the post, and then you'd get it back, and then you'd still have to single block and go through your code like crazy. And then if you want to change the way you're doing something, you're kind of always wondering, is that code going to be good or not? Um, so I think that was around the time where people were coming. Well, that was quite a few years ago, and then Vericut got really popular. Is it still popular? Or
Uh, maybe. I've heard of it and I've seen it, but I don't know anybody personally that uses it.
okay, so that's like to my knowledge, that's a complete competitor, is it
Yeah,
not? Yeah.
yeah. I
Okay.
think it was earlier to market than Camplete too, because I remember hearing about it like in college when I was learning Mastercam. Like we didn't have Vericut, but like there was plugins or something that kept popping up, and so like I knew of it.
Right. Yeah. So that whole like that was quite a few years ago. I know it's gotten a lot better as Spree has come out with sort of post processing simulation, if that makes sense. When I started with it, you could get this pretty picture on the screen, but when it went through post, like it may not be anything like what you saw on the screen.
Yeah, it wasn't true G code simulation. It was just cam simulation.
Yeah, and I'm like, well, what's the point? Just show me the insert cutting that. I don't really care that it has machine models. Like it's completely worthless, right?
Yeah,
Um,
exactly.
I think that's sort of being resolved in industry now with um, um, I think Esprit has their own G code simulator. I know NX does, and then I think a lot of people have, at least what I've seen online, uh, they go the Fusion because the price is right, and then they buy Camplete. Um, so your total cam package, if you will, is probably, I have no idea what Camplete costs, but I'm sure that's probably less than doing like NX or something. But
Yeah, we had Jeff on from Camplete, and I remember it actually being surprisingly affordable for what it is.
Yeah,
They
wasn't
even
it
have
like
a
5 to 9 thousand or something?
yeah,
yeah, that was
that's
the full 5 axis one. They even have like a 3 axis one that was even cheaper than that.
so yeah, that makes sense why there's quite a few people that I've seen have been using Fusion and then using Camplete. That sort of logically makes sense to me for what you were investing in. Um, but if you're spending 15 grand to get your 5 axis cam, by the time you include your seat and subscription and everything else, it better well do G code simulation, in my opinion.
Yeah, agreed for sure.
But yeah, so I also do design work. So I do patent work for people. Unfortunately, that's partially why the cogwheel always looks really hobbyish, and I love the hobby aspect of it, but I can't really post any professional stuff I do because of NDAs. Or when you're doing patent work, it's obviously you can't post stuff because then it defeats the purpose of a patent. So
Yeah,
it
yeah, exactly.
becomes prior art. Although if you have an idea and you don't want to go down the patent route, create a blog and post your idea, because that does prevent other people from patenting it. So
Oh, interesting.
yeah, um, at least you need. It's difficult because patents. You know, I was gonna say, Payton. You know how good a patent is, right?
Yeah.
Yeah, it's only as good as your lawyer,
Yeah,
Yeah,
and how much money you want to dump into it.
right? Um,
and really,
but
it's just a way for China to copy you.
in some ways too. So I'm always a proponent of, if you can be the first person to market, make your money and be efficient at what you do. Um, Patents do serve a purpose, but if you don't want to go down the patent route, one of the ways that you can provide yourself with some protection from somebody else patenting your idea is either publish it like crazy so it's all over the internet, or you can also mail yourself your ideas. Often, probably the best way is registered mail. And if you ever end up in court, at least you can prove that you had that idea before the other person did. So you may have more of a leg to stand on. I'm not going to say that'll win your case, but one of the things that I've realized about patent work, and I've done patent work since actually I got out of college, and the small company that I worked for had a number of patents, and they're like, realistically, we know we can't enforce our own patent, but it does prevent other people from patenting our idea and basically trying to submarine their company. Um, So that is something that you do always have to be a little bit worried about, because somebody can accuse you of stealing their idea, right? Even if you had the idea first.
Right. Oh yeah.
And I'm sure that happens all the time. But and most of the people that do accuse you of stealing the idea just want a big pile of money, and then they'll go away. But that's not always really nice. But anyway, so I do patent work for people, and for better or worse. And recently, I've moved to a larger shop, and I do have a couple of Tormach machines in my garage that are strictly for prototype work, and we can talk about those if you want. And what else? I don't know. I'm super fascinated with vibration. I've done a fair bit of vibration work. You guys can tell I'm a nerd, right?
Aren't we all?
Yeah. I think most of the people living or listening to this are, manufacturing nerds for sure.
We just called
So
out like 1,500 people, Dylan, saying
Yeah,
they're
I
all
know.
nerds.
They all know what they're doing.
Yeah.
If you're listening to a machinist podcast, or probably in the case of a lot of our listeners, more than one machining podcast, you love machining enough to be a self-proclaimed machining nerd.
I would hope
Uh,
so.
yeah.
yeah. No, it's yeah. So yeah, I'm a big nerd. I know. There's a bunch of nerds, and actually, to be honest with you, that's partially why I sort of got into the Insta Machinist thing. I really can't think of a better group of like. Is there a better example of good social media? Because most social media is, to be honest, it's probably trash.
100%. Yeah, I've never come across a group like the Instant Machinist group.
Yeah.
People are generally like encouraging, and yeah, some people have opinions, and I think that's good. I think we need to share opinions a little bit more. Like, I don't get offended when somebody posts, like, I'm gonna say, like, trolls me, like, in quotation marks. I think, like, you've said it too, Dylan, like, we're all armchair machinists, and I actually kind of appreciate that feedback. um, Maybe at first sometimes I get a little bit angry about it, but um, no, but like, yeah, like, I'm really amazed at how professional people are, but how willing they are to share, and for that, I'm very grateful. And it's fantastic to be on Instagram just to watch people post pictures of what they're working on. Like,
Yeah, I totally agree.
so anyway, I am fascinated with vibration. So have you guys ever heard of a company called Blue Swarf?
Yeah, I have. They're the
Oh,
ones that do the ring test, right? They're like the
yeah, yeah,
hammer
yeah,
test. Yeah.
yeah. Have you used it? I've never used it. I've only seen videos. So
No, I've been trying to convince all of my employers for the past like 3 or 4 years to try it, and nobody would.
that's interesting. So I've been working on. I had like, going back to the people. Like, I look back to the program I took at university when I was doing night school. I had this one professor who was an automation guy, and he was a vibration guy, and he was another one of those geniuses. And he worked in automation, and he had all these practical solutions for solving vibration problems. And we did these classes, and this was the type of guy that could teach something to a 6-year-old and they would understand it. And so I learned all this stuff, and then I came across Blue Swarf, and I'm like, I could probably do something like that in my garage, because the concept of it is actually quite simple. All they do is they basically stick an accelerometer on the end of the machine, like on the tool, and you hit it with a hammer, and then they plot the response of that accelerometer, and then they determine what the natural frequency is of the entire system. So that's the holder, it's the spindle bearings, it's the machine itself. So it's very, very machine specific, and then they use that to determine when that machine tool or that cutting tool is going to chatter. If anybody, I have no idea if Blue Swarf is good to deal with, if they're easy to deal with, if it's whatever. Like, I'm not recommending the company. I'm just looking at their idea. So I've been
Yeah,
toying with the idea of actually gluing on accelerometer onto a like an end mill and trying it myself, because the background of the process isn't that complicated. But anyway,
well, I think one of our listeners, I don't think he works for Blue Swarf, but Jody Olivent. I think I want to say he does vibrational analysis as his day job, and I've seen him like fly around the country to do like turbine blade type machinery, balancing, and all kinds of stuff. So like occasionally in his Instagram, I'll see something that he's actively balancing.
Mm-hmm.
So I wonder if maybe he can DM us or something, and we can talk about it in our next solo episode and kind of follow up on that point, because he would definitely know more than we would, how it works and how well it works and all that stuff.
Yeah, no, for sure. So that's something. Yeah, I'm fascinated with Blue Swarf. And then on the hobby side, yeah, I post YouTube videos. We do the Home Shop Machinist podcast, which I was going to talk with you guys. So I joke around online a lot that we were one of the first machining podcasts out there.
I think that's fairly accurate though, too,
Yeah.
right?
We actually predate the Business of Machining podcast, which is one of the older ones I know as well. But anyway, so the story behind the podcast is kind of funny, and I just want to tell this because I really appreciate your guys' show. The Home Shop Machinist podcast wasn't supposed to be exactly the way it is. Uh, I actually intended the show to be a little bit more professional, kind of like what you guys are doing. And my co-host drove the show off into the ditch on the first one. I'm joking, of course. And it's never been the same since.
It's just gone.
So yeah, it turned out to be something not exactly what I was intending, but it turned out I really like what it is. It's sort of this like Top Gear-esque machinist show. Obviously we have I call him the magnificent Max Phillips, and the Uberman himself, Stefan Goetzwinter, which you guys need to get on at some point.
Yeah.
Yes, we definitely do.
He's a co-host now as well. But anyway, yeah, I remember originally recording the first episode with Max, and Max is admitted on the show he doesn't listen to podcasts. He's not a podcaster, but we emailed back and forth, and I emailed him and said, I think you'd be a really good co-host. And he said, okay, I'll do it. So I created this like PowerPoint presentation because like I'm like a nerd book type, and we were going to talk about these slides, and like we didn't talk about any of it.
I appreciate it though. Like it's a nice difference from some of the only machining podcasts. You guys, dive into whatever beer you're drinking and some car stuff, and I'm like, yeah, I can hang out with these guys. Like this is what I talk about with my business partner. That's pretty much how our conversations kind of go all over the place. So I
right.
appreciate it.
It's good. But thank you guys for making a professional show.
I don't know about that, but we try.
No, it really is fantastic. Like from one podcaster to another, but also like from one guy in manufacturing to another, you guys are doing a great job. So
Appreciate
thank
that.
It's quickly become one of my favorite shows to listen to. And plus you always have great guests on, right?
Yeah,
I've
try to.
we've got to talk to some people that I've always wanted to kind of, have alone and be able to pick their brains versus like in a crowded room or something like that. So it's just great.
The other person you need to get on is Tom's buddy, Robin.
Yep.
Oh yeah. Yeah, well, we already got a great quote from him in Tom's episode, so now we're going to have to get him on.
Yeah. But yeah, seriously, I know I'm going down another tangent here, but Robin is one of the nicest people you will ever meet. And another one of them, I'm not going to call you old Robin because I know he listens to the show, but one of those older guys in quotation marks that you can corner, and you could probably spend 3 years learning from him. So
definitely. No, they're both on the list of people I'd love to have on. So,
but yeah, so hobby side, I do like, because like there's no segregation between work and fun. I'm trying to machine a Curta right now. If you guys know what a Curta is, a mechanical calculator that was built in the late 1940s.
Yeah, so let's kind of do a little bit of a deep dive on that. One of our guest question from Garrett Visser. I hope I'm not butchering that name, but one of his questions was, about tooling on the Curta, and I wanted to know more. I think the Curta is one of the coolest mechanical devices on the planet. Like I have wanted one since I found out what it was, and constantly I'm looking on eBay for one that's not $1 billion. So I want to know more. How did you come across the project? How's the project going? What kind of troubles and issues have you had on it?
Um, yeah, the Curtas, I agree with you completely. As soon as I found out what it was, I always wanted one too, and they usually go for about $1,000 on eBay. Um, Interestingly, if you what you paid for a Curta when they were first made, which was somewhere around $100, if you run it through the inflation calculator, it it would hold its value today.
Wow.
Um, so I don't know if you could say you could invest in Curtas, but if you bought one, you could sell it and get all your money back, which for a computing device is pretty fascinating. Um, so I stumbled upon the project. So all the drawings for the Curta are available online. Uh, you can find all the production drawings. I think I still haven't completed the 3D CAD model in its entirety, but I am 99% sure all of the drawings are there. And I only know that because I know the person who actually 3D printed a Curta using those drawings. Now he 3D printed it at I think 3 times the original size.
Yeah, he sent one
Um,
to Adam Savage, didn't he?
yes, and he's the fellow who sent one to Adam Savage, and we correspond. He's on Twitter, so we've messaged each other back and forth. So yeah, he printed a 3 times size. He's trying now, I believe, again to print one at 1 to 1. But uh, I thought initially, like you, Dylan, I'm like, oh man, I really want one of these, and all the drawings are here. I'm gonna make one. So like, how hard could it possibly be, right?
Oh, it's tough. Yeah, actually, it was such a shock to see you start the project because I want to say 2 or 3 years ago, before we had even got a new machine or anything like that, Brad and I, my business partner, we were like, man, one day when we get a fourth axis, so we can do all that complex work, we got to make a Curta. And then I saw you start to make one, and I'm like, oh, this is going to be so epic.
Yeah. If I can get through it, I will. I am taking a little bit of this from Robin Renzetti because he built a helicopter. I don't know if you saw that picture. It was on the podcast when we had him on. He built this model of a like a helicopter gearbox and tail section, and the work that he put into that was just outstanding. And for me, this is more of a personal skill development than anything else, just because I love machining so much. Um, the drawings are extremely difficult. You definitely need fourth axis, and you do need some CNC equipment, which I have in the shop now. So unless you've got like you're a Swiss watchmaker and you've got a Schablin mill and lathe with all the attachments, and like I'm talking about everything, uh, it's a difficult project, but it should be interesting. We'll see how it goes. Like I'm still working through the CAD right now. I'm a little bit further behind in the project than I wanted to be, but that's just because I have a family, and yeah, it's not gonna pay the bills. So I
Yeah,
do get people saying, "Man, I'd like to buy one," and I'm just saying, listen, I don't think you could make money selling this thing at $1,000. There
yeah,
are over
exactly.
there's 600 parts in total in the thing, or over
Jeez.
600 parts. There's
Couple
over
bucks a
100
piece.
unique parts,
That's so insane.
and just the story behind it. Because I'm a nerd and I love computers. Like I love computers and computing and mechanical devices. Um, like the guy that designed it when he was in a Nazi concentration camp, or at least finished designing it. And then he even the story behind it, like he gets out of the war. The business that his family had was all the equipment was worn out because they were making stuff for the Wehrmacht. And um, he had to basically they sold their business, and then he ended up in Liechtenstein, and he did this deal with a prince there, and then they tried to steal the patents from him and push him out the door. And then the business was poorly managed, so Curta or Conti AG never really made any money. Interestingly, it was ended up being bought out by Hilti, like the power tool company.
Really?
Yeah, so they actually owned it at the end, and they were still making Curtas there. But unfortunately, there are no pictures left of the factory. I've been corresponding with people all over the world about that. I can't get anything from what the original factory looked like, but it would have probably been mind-blowing, because a lot of people say, well, a lot of those parts would have been cast, but if you look at the drawings and you go through them, and I recommend anybody who's interested in manufacturing, even if you don't care about a Curta, go online, find the drawings for the original Curta and start going through them. I don't even know how people design this product without CAD, but even to make all these drawings, like if this was left up to me, like the drawings wouldn't even have been made properly. Like,
Yeah, it's just such an insane like thing. Like if you're listening and you've never seen a Curta, you've got to go at least look at a picture of one or watch a video of somebody operating one. It's just the most mind-boggling mechanical device. The fact that it does what it does, it's so bizarre. I absolutely love it.
so that's sort of the, yeah. I agree, and that's why I committed to the project. I'm hoping to have it done in a couple years, but we'll see. Maybe it's going to take longer. I have no idea.
So have you worked on any of the parts yet, or is it all strictly just computer work right now?
I've started on a few of them, just laying out some tooling work and stuff like that. I want to get the 3D model completely done. That's more me and my sort of OCD way of doing things, but maybe I should jump in a little bit earlier. But I haven't started machining a lot of stuff yet. To answer your question, no.
So far, what looks like the hardest part? Because like when I rough looked at the drawings years ago, the tubes, they almost look like gun barrels that the numbers ride on with all the sliders. Looked just insane.
Yeah, those. Yeah, I can tell. Yeah, you're right. You looked at them well, because there's lots of parts that look like they're crazy, but those parts scare me the most. There's these little triangle things, like they're used to revolve, and they all slide on the shaft, and they've got this really. It's not a circle OD. They basically stamped them. Those are parts that were actually stamped originally, and they've got like a 2 millimeter hole in them, but there's like a keyway that's part of the ID, and those parts may involve me dropping off a case of beer at somebody who has an EDM. I don't know.
Yeah.
Robin has told me how to make the parts manually, or like with a CNC mill. You may be able to broach those. Those parts scare me a lot too. But yeah, there's these long 2 millimeter shafts that have spirals, so it's fourth axis work. But because they're 2 millimeters in diameter, but they're like almost 3 inches long, and you have to machine a spiral down the whole part of the part, that's going to be very difficult.
Yeah, I'm looking at a picture. It's like fluting on a gun barrel, like you were saying.
Except, yeah, it's like a 2 millimeter shaft.
Yeah,
And
tiny.
it's super deep too. It looks like it's almost halfway through the entire,
like a drill bit flute, really.
Yeah, exactly.
So I'm really hoping for parts like that. I'm going to be using free cutting steel. I don't care what the original drawing said. And in that sense, my replica will be different, but I'm hoping other than that, it'll be 1-to-1, but we'll see how it goes.
Well, I'm definitely paying attention and looking forward to seeing how it all comes out, because it is super, super cool.
Yeah.
Well, we've got some questions, some that are actually we can kind of just run through, I think, and then a few more from Garrett that we can go through as well.
Sure.
So best favorite machine you've worked on, and I'm guessing it's probably a Miyano.
Yeah. I went on to this podcast with, like, I had to say it to myself a few times. I'm not going to bash Haas. I'm not going to bash Haas. I'm not going to. Sorry, Payton. I'm sorry. I actually secretly, I really, really admire Haas. I will put that out there. As much as I bash them, I would, if I needed to buy a certain type of machine, I would seriously consider Haas. But I am a huge fan of anything, not anything, but most Japanese machine tools. because of the work that I've done in reliability, and because I've worked primarily on Japanese machine tools, I've worked on some hard inch stuff and stuff like that, but there really is no comparison in my mind,
Other
to
in price.
well, yeah, if somebody else is paying the bill, right? Which is why
Exactly.
I but for me, so this is the thing, this is why I admire Haas. But so if you're going in, and when we put these machines in, like when we did this sort of project quite a few numbers of years ago, I thought about Japanese machine tools a lot, and the subsequent machines were put in were more Mianos just because of this. But if you're making parts every day, the last thing you want to have happen is your machine break down. Like that costs you a lot of money, right? Um, like like if you have a machine that's like down for a week and you can't get out your customer's order, you told them that you were going to ship them, next week, and now you got to call them up and say, hey, my machine's broke, can I ship it to you next week? I think sort of that intangible cost of keeping your schedule and all that is worth a lot. You know what I'm saying?
Definitely, yeah.
Yeah.
The thing that I respect Haas for a lot is because I don't think anybody does parts and service better than Haas. If your Haas machine is down, I know, depending on where you are, and even where I live in Canada, I know you can probably have somebody there next day, and they probably will have the part either in their vehicle or they can get it to you the next day, and you'll be up and running again. So, which you don't get as much with Japanese machine tools, because a lot of times, sometimes the parts have to come out of Japan unless you're dealing with a really good distributor. But the reliability of machines is huge, and that's why I like Fanuc. People make fun of me all the time, not just online, but friends of mine that work in manufacturing, and I say I like Fanuc, and they're like, why do you like Fanuc? I said, yeah, the interface is horrible. um, when you type something in MDI, as soon as you go off the screen, it's gone. Like,
Yep.
but I said to them, I said, you know what? I have a machine that's got Fanuc drives and a Fanuc controller. It's 15 years old and it's got 25,000 working hours on it. And you know what? Fanuc's never been called. Like,
Yeah.
Exactly.
and if I do have to call Fanuc really does a good job with parts and service all over the world. They take that
Yeah.
extremely seriously. Here in Canada, if I called Fanuc, because they did have one part break on a Fanuc on one of the Mianos that I set up, and it was an encoder that went bad. The guy, I called in the morning, the guy was there by lunch, and the part was, the machine was up and running again. Oh,
Yeah, they do a really good job as well. But yeah, Haas, I agree. A friend locally, Brad Southard, he's Southard Knives.
mm-hmm.
He has a VFO, I think, like the original Icebox Haas,
Okay, yeah,
and I can't remember what he said he had go out on it, but he called up the HFO in Phoenix here, and they're like, "Oh yeah, we've got that part on the shelf." And he
yeah.
was like, "What? Like this is a 20-something-year-old Haas?" And they're like, "Yeah, no problem. We'll have it out there later today." Like, so yeah, it's pretty amazing.
So, yeah,
So, but best favorite machine? So a Miano, was it the first Miano that you love the most, or?
no, I really like the Miano BNA DHY. That's
I
a
think
really
seen you
good
talk
machine.
about that on the Discord.
Yeah, and I do post pictures when I can. I have a few pictures because the company that I used to work for, that's one of the companies I do contract programming for. So I do go in and set up the machines for them, but or processes. They have operators and setup guys, but uh, that is a really good machine. It's kind of crazy because there's two turrets and main spindle and a sub spindle, and setting it up is kind of hairy, but um, it's the only machine, like Mianos really are like if you're working to within a thou, like I know people were talking about like warm up programs and stuff. Like they do warm them up there, but like you can walk in, turn a cold Miano on, and it's going to be within a thou of what you shut it off at. Um, Like I really like those machines. And
Yeah, another.
that's without glass scales. Like they don't have glass scales on the axes. They just use very good ball screws. They tension them. You know, it's all done mechanically, but just super accurate, super reliable. Like if you have the job for it and you think you can make it work, it's almost like printing money once you get them set up. Like
Yeah, Easton has a few from Maria Manufacturing,
yeah.
another friend of the show, and he absolutely loves his. So
Yeah,
I've
he
heard nothing but
nonstop.
good things. Yeah,
Yeah, Miano. Well, I know uh I, it's Frank at Mary Tools running a couple of them too, or he has a number of Mianos in the shop.
yeah, he's a big fan as well. I will say the combo feed rate rapid knob is a little bizarre, but I've heard nothing but good things about the machine otherwise.
Yeah. Yeah. Did you know that Payton? It's all in one dial.
Yeah, that's weird. Yeah.
I
Actually, it
love
works really
my
well.
I
But
can picture it, but I kind of like the idea of being able to control it separately.
cows. But all right, well, I guess so. Future additions to your shop. So you said you have a Tormach, or is it two Tormachs now?
I have two. I have the lathe and I have a 770M.
Okay,
So,
and then anything in the future you're going to add?
um, no, I don't know. I'm pretty busy. I would like a decent surface grinder, but I have one. I have to put a spindle in it, but uh, I don't know. I think I'm happy right now. Um, Tormachs are not. I can talk about Tormachs. Like I'm not like one of their brand ambassadors, if you will.
But give
You
us
can
the
ask me.
lowdown.
You want the on? Oh, so I've bought. Like I said, we put in prototype one, so I'm very familiar with the machines from before. So that is why I bought other ones. Um, I don't know. They're kind of expensive for what they are, but then depending on where you are, buying a used machine tool may not be possible, or you may not have space. So I'm just in my garage, so I don't have a lot of room. So they worked out really well for me in that regard. Uh, let's see what else. What is I going to say about Tormach? Oh, so there's lots of people who want to make their own CNC mill, and if you do that and you look at the amount of money you're going to spend and you include your time, for what Tormach is charging, it's really not that bad. Um, so they really are. If you want a machine that works not too badly, and Path Pilot actually is half decent. Um, like it's based on Linux CNC, so it's actually really good. In some ways, I like it better than Fanuc, but which isn't saying much for Fanuc, I don't think. But
I've
um,
actually heard pretty good things about Path Pilot, though. Yeah, it seems like a pretty good control software.
Uh, I think the biggest problem with Tormach. So when I bought the machines, I bought the base machines, except I bought the stand with my mill because I couldn't make the stand for what they wanted. Where Tormach really gets crazy is if you want like a fully optioned machine, and then it's like, well, why don't you just go buy a Haas?
Yeah,
But if
yeah,
you look at their base machine price, so I bought a base lathe and I made all my own tooling, and I bought a base mill with the stand, and it's fairly reasonable. But like what they're charging for their MX machine, like $25,000 or something, that's crazy. Like,
Yeah, it's the
like
same starting price as a Haas.
right. And I don't think I'd do that. I'd just jump to the Haas because you can run the Haas on single phase power too. But like the 770 or the 770M that I have here was less than $10,000. It was a fair bit less than that. So it's kind of like buying a car. Do you know, like when you buy the base model, you get like the base model is exactly the same as the one that's the luxury edition or whatever you want to call it. But so like the base model of a Tormach is exactly the same as the MX machine. Like it's doesn't like it's not like it has bigger dovetail ways or anything like that. So I just don't see a lot of the value in sort of their pricing structure, but I understand that's how they're making their money. Just like car makers make their money on options.
right, yeah. So
But
that
the
kind of bookends into one of Garrett's questions, though, is he said you bought the how-to books for an EDM. So are you planning on building a wire EDM?
It wouldn't be wired, probably be sinker.
Ooh,
I'm thinking about it. Wire ED or like any or any EDM machines actually fairly easy to find and get one. Most of them are whipped, but uh, like from a used standpoint, yeah, I don't know. I may build a sinker EDM just for the Curta itself. There are a couple pretty simple plans out there to build your own sinker EDM that work fairly well. Uh,
I did not know this. I need to get in on this.
well, you're probably too busy, Peyton, to be spending time.
Nah, I got time.
Yeah, it's the other 40 hours a week.
Yeah.
Yeah,
So you've seen those things like in, I don't know, what tooling flyers. They got like the tap extractors.
Yeah,
yeah.
yeah.
So there is a design for a sinker EDM online. There's a couple guys who made them that function essentially similar to a sinker EDM, but I have this idea in my head that you could slap one together fairly quickly. Of course, that's just the way my brain works. It's always takes way longer than I think it's going to. But if now with like reasonably priced linear guides, like you could put together a sinker type machine that would work fairly well. Um, I was friends with a guy who they have like a model, like a home shop machinist modeling type club in Toronto, and somebody there brought one in and did a demonstration. And these like like if you're really into machining, you should subscribe to the Home Shop Machinist. I'm not saying that because they pay me. I don't get paid anything from them, but you see what a lot of these like old guys do with model work. Like it's absolutely fascinating, and they use some of these guys use these things to make parts. So they do work. They're slow as all get out, but for prototype work, I think it's really good.
Hmm, that's pretty cool.
Yeah. And then I guess that
Uh,
kind of goes to a question we have is what project has forced you to learn the most lessons? Because I know it sounds like you've got a couple projects going on.
Um, Obviously the Kurt is going to force me sort of on my machining skill because that's the thing in all this. I didn't say this, but I'm not a machinist. Like I never went to trade school. I didn't start up in the tool shop. I or the tool room. Like I don't. I'm not. I didn't do any apprenticeships. So um, yeah, I think that project's going to definitely force me to learn the most. Sort of life picture wise. I think, obviously, buying a multi-axis lathe and learning how to use it, that was very challenging.
yeah, I think you kind of started the episode off with what your most difficult one was right off the bat, huh?
Yeah, I don't know, but I do look back on the like some people don't want to go to school, like because when I went back to school to do my degree, that wasn't easy either, not with kids at home, but I think it's worthwhile. I don't underestimate the um, the usefulness or the importance of formal education if it's properly applied, if that makes sense.
Yeah, definitely. Learning when it's not just for the degree.
Hmm.
Yeah. Another question we had was, what's the most underrated tool in your shop? Or it could be in anybody's shop. Like, what do you think gets the least amount of respect and deserves more?
Hmm. I don't know. That would depend on the work you're doing, but I honestly would have to say maybe I'm wrong. Maybe you guys can is a good like a good milling vise
Okay.
personally. Like I don't know. I've had bad experiences with like bad milling vices, but like a vice that you can go to and count on every time you load stuff into it. To me, that's huge. But any work holding really, but like a good quality. I wish Eric at Orange would make a good quality small milling vise, like a traditional CNC one. I know they got the 5-axis one, but
Yeah, no, I think that I mean, it didn't sound like when he was on that it was one of his near projects, but I would love to see a smaller vise from him as well.
Like
I
a
know they were
four.
making a 4.5 for a little bit. Like Easton's got one, but I think it's a discontinued model now.
Oh, because I was going to say, to my knowledge, and I get why he does it. Like he's got to run a business, but is the smallest one he makes is a 6 inch?
Yeah, 6 inch and like I think 17 inches long, something like
I
that.
think it's 16
Yeah,
because I have the 16, I believe.
Okay, then yeah, 16. But yeah, I know at one point he made a 4.5 inch vise, but I don't think that that was a long lived product line.
yeah, I get that.
Yeah. Another question we had was, what's the biggest pain point in your shop? And I guess a follow up question is there anything you're doing about it?
Hmm. I don't know. For me, I think the biggest pain point for me is, and I'd be curious how you guys handle it too, but because you guys are really busy too, but for me, it's time management. Like, like
Very
how
overlooked, definitely.
well, like I have equipment, and it's one of those things where like time can solve a lot of problems, right? Like if you just had an extra day, you could put that time into developing a better work fixture. You could do your design of experiment, or you could um, you know what I mean? So like for me, and then yeah, obviously having three kids and doing doing work every day. Right now with COVID, my kids are at home, so we're doing homeschooling uh, every morning. So that's challenging. Like how do you guys handle time management? Because like Dylan, you got a full time job too, right? And
Yeah.
Peyton, like you're going Mach 3 with your hair on fire. So like, how do you
Lately
guys do that? Like,
for me it's been throwing money at the problem to gain some time back.
oh,
So we bought the new mill, and probing and tool setting has really saved a ton of time. And just like being able to load programs over Ethernet versus RS-232 is like, I'd say I saved more time just going to that than anything else that I've done in the last 6 months. Like that was such a big pain point on the kitty that I can't believe that we didn't do it sooner. And we bought that orange palette system that I still need to get on there, the orange 0 point system. In efforts to try to do that, I've created a whole bunch of Fusion templates to speed up programming, and it's really just spending some time and money up front to really get my process as absolutely dialed as possible. Because yeah, like you said, we're everybody is busy, and the more time, or the more time I can optimize in the shop where I'm actually making parts and not setting up and not programming, that's money being made.
Yeah, and for
yeah.
me, it's, okay, I've got 50 orders to pack. How can I be lean about this and minimize movements? Why am I walking over here when I could just be doing it right here? And, you know, why are the bags over there? Why are the envelopes over there? Put that, next to each other. It's all those little things, right?
Yeah. Yeah, I keep forgetting about that Peyton, your parts are tiny and you got to package them all and ship it. Like that's a lot of work.
A lot of time.
I think that's the
So
truth.
yeah, I wish I had more time, but I think everybody says that.
Yeah, yeah. I mean, I think that, like you said, time can solve so much, especially when you have a good work ethic. Like if I had an extra day, I probably wouldn't spend it relaxing. I'd probably spend it in the shop and, you know, get some more work done or something like that. So yeah, I'm right there with you.
Yeah, or at least spending time to like take a step back and just observe what you've been doing, and it's like, how can I improve this? I feel like I've been doing this a lot. Like, can we remove this task or whatever?
Hmm. Yeah.
So another thing that I had a question on, because it seems like a home shop machinist podcast isn't a home shop machinist podcast without some automotive stuff. So I figured I'd bring some of that over here and say, what in the automotive world has been catching your eye lately?
Oh boy. Now you guys have to answer the question too, though, if we're gonna do this properly.
Uh-oh.
Okay, I'm get totally.
It's your show. Sorry, I'm overstepping my.
Yeah, who owns this one again?
Yeah, I don't want you kicking me out. Like,
I
And on
asked the
this
question.
week's episode,
yes. I'm the Canadian. I'm supposed to apologize for my bad behavior. I'm sorry.
yeah, whip you into shape.
Okay, so you know what? I actually talked about this on Discord, so Dylan knows it. I don't know if Payton. I think Payton's too busy, and I'm on Discord because I'm supposed to be homeschooling my kids, but or I'm programming. I'm programming in Fusion, and I'll open it up. But let's see. So I really, really like Tesla, and I absolutely hate them.
Isn't that the truth?
I really like Elon Musk, but I also really hate him. Hate's probably too strong of a word. I dislike some of his business practices. So I'm interested in Tesla, specifically the Model 3. I think what he's done with the electric motor in that vehicle is absolutely fascinating. Because they did a few things, and if you guys are really interested in Tesla, or any of your listeners are, go over, check out the Autoline After Hours podcast, or if you're into cars at all, and that's a pretty big podcast. Anyway, that show, they have a guy who his name's Sandy Monroe. Actually, they take apart an entire Tesla 3 Model 3, and they go through the vehicle and they talk about all the stuff that Tesla has done, which is absolutely fascinating. And Sandy Monroe previously absolutely despised Tesla. He thought that they were a garbage company. And after they took the car apart, he's like, these people are brilliant. But I still hate the Tesla. I don't like their vision for the future for like the tactile controls in the car. I think the big screen in the center is awful. Just from an ergonomics standpoint, I love being able to touch switches without having to look down at what I am doing. So I like Tesla. Probably my favorite car right now, because I'm one of those. And it's not just because I think that I'm like 20 years old anymore. No offense, Payton.
Oh my gosh.
I like the Subaru BRZ. That to me is my favorite new car right now.
Okay.
It's like one of those, like, go fast, slow cars.
Yeah. That's. I think it's an awesome idea. I think it's about 100 horsepower too light for me, but
Do you think so? Okay, you just
well,
gotta put smaller tires on it.
I've got an 85 Toyota MR2 that I'm planning on dropping a turbo motor into because it's the same thing. I mean, it's 2,200 pounds and 100 horsepower, and it's like I can flat foot it everywhere, which is a ton of fun. But I would love to have another 100 horsepower on top of that. So, I do. I've driven in one, and they're really nice driving cars, but
Just not enough, eh?
I just think they need an STI version, and
I think they would sell like crazy if they put that engine in there.
yeah, I just think that they can't risk cannibalizing WRX sales, and so that's the reason they haven't done it, pretty much.
Right.
So, but no, that's a good answer. I definitely sympathize with your Tesla thoughts. Like I'm not a big fan of using Twitter to raise your stock prices and things like that, but I do think that what they're doing and the way they're changing the conversation about electric cars is like really quite amazing.
Mm-hmm.
Yeah.
I think Tesla has amazing people working for it. It's the same thing with SpaceX. Like,
Yeah.
Elon's the front guy, but the people behind the scenes are really, really, they're amazing engineers. They're very good at what they do, and at least they're trying to change things. So.
Yeah. I mean, it was like Jeff said 2 weeks ago. Like he worked for Elon, and like that kind of personality and genius brings that kind of personality and genius to them. So like they really do have an amazing team at both companies.
So
Yeah.
what car for you?
So I guess technology wise, the thing that really I think is super cool is like the electric boosted turbos that are coming down from F1 Tech now.
Okay, yeah.
Like I think that that's just such an interesting technology and like solves so many issues with turbos that I don't know. I'm looking at the Borg Warner version of it right now. That's I'm sure is going to start popping up on consumer cars soon, and like it's just such an interesting idea. And then as far as cars, like I don't know, there's quite a bit that I think is really cool out there, but like if there's one that really I don't know if it captures my heart, but like one that's just super cool is like all of the new McLaren stuff. Just real, it's like insane that they using the same motor more or less that they've been using for like 5 or 6 years now, and it's like one of the fastest cars on the planet. You know, it's absolutely bonkers at fast. Like I come from riding motorcycles, and there's like a million comparisons of what is it? I want to say 650S, but like there's a bunch of videos of it versus like a leader bike, and it more or less matches it and then beats it. And having ridden those bikes, that is just so insanely fast. So
Yeah,
our
that's nuts.
720S is what I was thinking of. Yeah, they're just it's insane. So
Come on, Peyton.
I'm just not a car guy. But like I agree with some of the things you said about Tesla, and I think what was so interesting to me is a while back, I've been a long follower of Tesla. I've owned their stock since I was in high school and I've done really well with it. And, you know, looking at their business plan, I think it's so cool. If you really look at how he planned the whole car evolution, the Model S was such a big deal. Um, and the original Roadster, it was really interesting. If there's this one video, I'd have to find it, but it explains the transition from the original Roadster to the Model S and how that was such a big deal. And I just think it's really cool how it seems like Elon seems to have really good plans like 5 years down the line. And I think that's really cool. And then, I have a Toyota 4Runner myself. And just, I don't know much, but all I know is everyone talks about Toyota and how they're so reliable. And obviously, lean comes a lot from Toyota and the fact that, this company can make these super affordable, but super, in my opinion, I mean, I guess high quality or reliable. I guess pick your poison on whatever word you want to choose there. But I just think that's a really cool thing for a company to be able to do and for so long.
Yeah, I hey I love Toyota too. We have a Toyota Sienna though, but that's because I have 3 kids.
yeah, you kind of
But
have to have a van at that point.
but the V6 in that thing is fantastic. I can't think of a better engine, really.
Toyota makes some fantastic motors. They really like they straddle that line between power and like decent to drive and super reliable. Like you're like, oh, I could drive this fairly aggressively for 200 plus thousand miles, no problem.
Mm-hmm.
So yeah, I'm right there with you. So we had one more question from Garrett, and he said he thinks you've mentioned that you don't like the TTS system in the past, and he wanted to hear what your comments were on that.
Um, it has to do with vibration and chatter. Now, like these are really light machines, but if you look at TTS, it's like you're holding all your tools in a collet, and the stub length is like only like an inch long. Uh, I don't know. I know they need to use it if you want a tool changer. I don't like the jobs that I do in my prototype shop are not um, really cycle time dependent, if you will, nor are they complicated enough for me to warrant. Like I'd love to have a brother in my garage, but I just change tools out and I use R8 on everything. Uh, and I've had really good success with it. And I've used TTS on the prototype machine in a prototype cell that I set up quite a few years ago. So they will walk out. Uh, I don't know. It's a half baked solution. If you want to do uh, like with the tool changer, just go and buy the BT30 or whatever the BT spindle that they have, and don't bother with the TTS. but that's just my
Yeah.
2 cents.
Well, I think that them including a BT30 option on the newest machines kind of is a sly acknowledgement that TTS is a half baked system for sure.
Yeah, like I I actually spoke with the founder of Tormach, Greg Jackson, because it was a fairly young company when we bought the machines originally, and he was really like it really they've kind of taken it away. Their slogan used to be something like, what was it, prototyping your ideas or something like that.
Hmm.
And that's exactly what it is. Don't buy a Tormach thinking it's a Haas. um, and I think the TTS kind of goes in with sort of his mindset. Like he was really focused. Greg was really focused on getting a CNC machine that people didn't have to build themselves, that they could play with in their garage. Uh, but the TTS really kind of cut it short. So it's really just a chatter, tool walkout, and run out issue. Um, I have a 770M, and I have about 1/10 of run out, like 1/10 of run out on the spindle, measuring it with the DTI, which is pretty good for what the machine costs. Uh, but as soon as you put a TTS in there, like the collet isn't very good, and then they're holders. So by the time you do all that, you have so much run out with small tools. Like, what was the point? Do you know what I mean? Like,
Yeah,
I
totally.
so I just do everything R8, and people say, well, it's not repeatable. It repeats fine. Uh, it's it stops up against a taper. Uh, I don't know. So, but yeah, that means I get to monkey with tool changes. But hey, like I said, I don't have the cycle time needs for the work that I'm doing. But if you do, please don't buy Tormach. Go buy a Haas. Like, you might be disappointed. Lots of people have made good money with Tormachs. I'm not dishing them or dissing them about that, but it is a machine that is a hobby prototype machine. Don't think it's anything else.
Yeah, that's fair.
Fair statement.
So to wrap up, I think one question we skipped over is, and one thing you mentioned in the beginning is, what is a technologist? So this is a good bookend to your story, and kind of let us know what you do.
No, that's a good question. So I do have a question for you. Like, do technologists exist? Are you familiar with the term?
I had never heard of it until I saw your website.
Yeah,
Okay.
neither have I.
So it is a Commonwealth, and Commonwealth countries it's very popular in Canada and Britain, and well, Britain's not a Commonwealth. They are the mother country,
They're the what?
Australia. I joke with people, and I will joke here, and I know this is a family friendly show, and I appreciate that about you guys. So once in a while, tongue in cheek, I say a technologist is an engineer's grunt. Um, you can put a different word in there that starts with B if you'd like. But all joking aside, a technologist is, I don't want to say not quite an engineer. Um, it does a lot of what an engineer would do, but maybe not with as much theory emphasis, if that makes sense, and replace that theory with practical. So I tell people that oftentimes engineers will answer the why something works. And they do that with a lot of theory and a lot of mathematics. And they have all that background information, which is really important in certain industries, especially when you're taking public liability, that you need to know that entire um, background of information to do your job properly. And as an engineer, I get that. In some cases, I think it's a bit overblown. Ask any engineer when the last time was that they did differential equations, and I think a lot of them will say it's been a really long time. But a technologist is as a technologist in Canada and in other countries, we a technologist, I think the best way to sum it up is they focus more on how am I going to solve the problem, what technology am I going to use, or how am I going to implement that technology to uh, to solve your particular problem. And the example I give is oftentimes with CNC equipment. Um, do you need to know how to tune servo motors to properly purchase and implement a piece of CNC equipment?
Of course not.
No, and engineers may spend a lot of time learning how to tune servos, and I know how to tune servos because I went back to and did my bachelor's degree. But um, you more need to know, like, how am I going to use this technology to solve your problem? So it's more of a hands-on approach uh, to solving people's problems.
Okay, that makes total sense. That's kind of what I thought it was just from the name, but yeah, it sounds like I probably would have ended up in that career track had that been an option at the college I went to.
Yeah, so it's basically it's an engineering degree that takes out a lot of the math theory and replaces it with practical labs. Uh,
Yeah,
I was in school for 4 years when I went to community college, and then I did another 4 years at university. But we did a lot of lab work. So we programmed PLCs. We actually learned how to use. We used Inventor when I went to school. Whereas a classic engineering degree, they don't teach you CAD. They just say either learn it on your own, or you know what I mean. Like, there's no official class where you learn CAD or CAM or whatever.
yeah, we had
Um,
one semester of it, and it was AutoCAD and SolidWorks, and it was the most rudimentary. Like, this is what CAD is. Make one thing. Okay, you're done.
right. So
So yeah, definitely.
whereas, like, in my when I remember way back, like, all our projects had to be fully CAD, full detailed drawings. Everything had to be handed in. You had to submit your solid model. The teacher would go through that, right? So, um, yeah, it's kind of like a shop floor engineer is a good summary of it, uh, in a sense.
I feel like we need more of those kinds of people. So
Yeah.
I definitely appreciate that.
Like,
And as a
yeah. Sorry, go ahead.
I was going to say, as a quick funny story, a good friend of mine is a engineer at a aerospace company here, and the last time I can remember us talking about differential equations was he was downloading a movie from some website, and it was super slow, and he laid out all of the rate of download and the rate of change of download and wrote up all of the equations to figure out when his download of his movie would be done.
Jeez.
That's the last time that I remember. I'm sure he's used it since then. It's been probably 6 years, but that is the last time I remember us talking about differential equations. So when you said that, it kind of immediately sparked that story.
But it's a rite of passage in classic engineering school, right?
Oh yeah,
You
yeah.
got to do it.
Got to
And
do diffie Q. You got to do vector calc. You got to do all that fun stuff. And yeah.
so, huh.
Well, that takes care of all our questions. And we're running up to 2 hours here, so we should probably wrap it up. But we usually give we usually give our guests a chance to kind of plug all their stuff. So your YouTube, your podcast, all that stuff. Let people know where to find you, what to look for.
Yeah, I am the cogwheel everywhere, including YouTube, Instagram. I have a blog, thecogwheel.net, if you want to get in touch with me. That's and like I said, that's all mostly hobby stuff, but hey, that's what I enjoy posting. So if you want to reach out, for sure. Thanks for the chance to plug myself.
Yeah.
Of
Thanks
course.
for coming
And the Home
on.
Shop Machinist podcast is
Oh,
everywhere you can find podcasts.
yes, the Home Shop Machinist podcast is everywhere you can find podcasts. Releases are sporadic because it is a hobby. Um, I think we went almost a year. That was just because I talked about it on the show, just family sickness issues, but that's fine. So we record when we can. It makes it hard. I know you guys know for scheduling. Um, Stefan's in Germany, so basically Max and I can record on Saturdays or Sundays. So just because of the time zone difference. So that
Yeah, definitely. Well, even getting you on, we were happy you were able to accommodate our schedule. We really appreciate
Yeah,
hey, the
seriously.
kids were in bed. It worked out perfect.
it.
Yeah.
Well, again, thank you so much for coming on. I learned a lot. I've already got 2 or 3 tabs up on what was it, Mini Clip
Mini tab.
or Mini Tab? Yeah, Mini Tab, of course, it's right there. And now I've got a big deep dive that I need to go into on design of experiments because I work in a production shop and we don't use any of this, and I can definitely see using it. So
They're not to plug them. I have no affiliation with Minitab, but their quality trainer, they have a learning package that goes along with it, is fantastic. Force yourself through it if you want to learn Minitab. After you're done that, you'll know a lot. So
Awesome. Well, again, thank you so much for coming on. I'm hoping everybody enjoys it as much as I did. Like I said, I learned a ton, and I really appreciate you coming on.
yeah, thanks for letting me nerd out, guys. Thanks, Payton. Thanks, Dylan. I appreciate it.
Yeah, thanks again, Justin. And everyone will be back on next week with Dylan and I.